At 2:17 a.m. on March 14, 1943, Chief Engineer Harold Bennett stood in the freezing engine room of the SS Robert E. Peary, watching a German torpedo wake cut through the black water 400 yards off the starboard bow. He had maybe 8 seconds before impact. The cargo hold directly above him contained 3,000 tons of aviation fuel bound for England. If that torpedo breached the hull where it was supposed to, Bennett and 62 other men would vanish in a fireball that observers would see from 20 miles away. But something impossible was about to happen. The torpedo hit exactly where German submariners aimed, right at the waterline, mid-ship, where Liberty ship hulls were thinnest. Bennett heard the explosion, felt the deck lurch beneath his boots, waited for the secondary blast that would end everything. It never came. What Bennett didn't know was that 3 weeks earlier, a 34-year-old maritime engineer named Joseph Lazzaro had done something that could get him court-martialed, something so simple that Navy brass had laughed when he first suggested it. Joseph Lazzaro was 34 years old, the son of Italian immigrants who ran a construction company in Brooklyn. He'd spent 12 years pouring concrete for bridges, highways, and building foundations before the Maritime Commission hired him in 1942. They needed engineers who understood stress loads and material science. What they got was someone who understood how to make things that didn't break. Lazzaro had been at the Baltimore shipyard for 7 months. His job was technical oversight, checking welds, reviewing construction reports, signing off on completed vessels. He'd watched 23 Liberty ships leave the harbor. He'd attended memorial services for crews from 11 of them. The math was brutal. By March 1943, German U-boats were sinking Liberty ships faster than American yards could build them. A single torpedo hit was usually fatal. Ships weren't designed for combat. They were merchant vessels, mass-produced cargo carriers with thin steel hulls optimized for speed and capacity, not survival. Lazzaro knew exactly why they were dying. Liberty ship hulls were 5/8-inch steel plate. A German G7e torpedo carried 620 pounds of high explosive. When that warhead detonated against the hull, the blast punched a hole 8 to 12 feet wide. Seawater flooded in at thousands of gallons per second. Ships went down in 4 to 7 minutes. Most crews didn't have time to launch lifeboats. The worst part, Lazzaro had watched engineers propose solutions for 5 months. Every suggestion got rejected. Add armor plating? Too heavy. Ships would sit too low in the water. Thicken the hull? Would slow production by 40%. Install bulkhead reinforcements? No budget authorization. The Navy's position was clear. Liberty ships were expendable. Build them fast, load them full, accept the losses. The first name Lazzaro wrote down was Thomas William Hendricks, 29 years old, from Galveston, Texas, second engineer on the SS John Morgan. Hendricks had worked the Baltimore shipyard before volunteering for sea duty. Lazzaro had approved the final inspection on the Morgan himself. On February 3, 1943, a torpedo hit the Morgan at 4:43 a.m. in the mid-Atlantic. The explosion breached the engine room. Hendricks was on duty. The ship sank in 6 minutes. His body was never recovered. Lazzaro found out 3 days later when the casualty list came through. He remembered Hendricks. They'd talked about engine room ventilation during the final walkthrough. That same week, Lazzaro learned about Raymond Fisher, 31 years old, Philadelphia, chief engineer on the SS James McKay. Fisher had a wife and 2 daughters. Torpedo hit at 11:20 p.m., February 9th. The McKay was carrying munitions. The secondary explosion killed everyone instantly. 41 men. Lazzaro had signed off on that ship, too. By mid-February, Lazzaro stopped sleeping. He'd lie awake calculating tonnage, blast radius, pressure waves. The problem wasn't complicated. The hull needed something to absorb explosive force before it reached the steel. something that would dissipate the shock wave. Something cheap enough that the Navy might actually approve it. He thought about bridges, about the retaining walls his father's company had built, about how concrete absorbed impact force that would shatter steel. And then he had an idea so simple that he spent 3 days convincing himself it couldn't possibly work. The technical issue was straightforward. When a torpedo warhead detonates, it creates a pressure wave traveling at 15,000 feet per second. That wave hits steel and transfers energy directly through the metal. Steel is strong but thin. It tears. The thinner the steel, the bigger the tear. Liberty ship hulls were 5/8 inch thick because they had to be. Thicker steel meant heavier ships, which meant less cargo capacity, which meant more ships needed, which meant longer construction time. The whole Liberty ship program was designed around one principle: build them fast. Navy engineers knew the hulls were vulnerable. They'd run the calculations. But adding armor plating would add 600 tons per ship. That meant redesigning the whole vessel. That meant stopping production. That meant Germany winning the Atlantic. So the official position was, accept the losses. Lazzaro requested permission to test hull modifications in January. Denied. No authorization for experimental changes. He drafted a formal proposal suggesting reinforced internal bulkheads. Returned with a note. Outside contract scope. He asked for a meeting with the Maritime Commission's chief engineer. Rejected. No meetings on unauthorized modifications. The bureaucracy was clear. His job was to build ships according to approved specifications, not to redesign them. On February 18th, Lazzaro learned about Michael Chen. 26 years old. San Francisco. Third engineer on the SS William Clark. Chen had graduated from Cal Maritime Academy 2 years earlier. Torpedo hit the Clark at dawn, 300 miles off Newfoundland. The radio operator sent 3 messages before the ship went down. Torpedo starboard side, engine room flooding. Water at chest level, losing power. Abandon ship, abandon ship, abandon. The transmission cut off. 38 men died. Chen was trying to shut down the boilers when the second bulkhead failed. The water pressure crushed him against the engine block. Lazzaro got the report on February 23rd. He read the damage assessment. Torpedo hit exactly where German tactics dictated. Mid-ship, waterline, aimed at the engine room. Standard attack profile. The blast had punched through the hull like paper. That brought the count to 37 Liberty ships lost in 6 weeks. Most went down in under 10 minutes. The U-boat crews didn't even need to fire multiple torpedoes. One hit was enough. Lazzaro knew how to fix it. He'd run the math. A layer of concrete against the inner hull would absorb 60 to 70% of the blast energy. The concrete would crack and crumble, but that was the point. It would sacrifice itself before the pressure wave could tear the steel. The ship might survive. The crew might live. But he couldn't get approval. Every channel was blocked, and every day he waited, more ships sailed. More torpedoes hit. More engineers died in flooded engine rooms. On February 24th, Lazzaro made a decision that could end his career. The SS Robert E. Peary was scheduled to launch March 1st. Lazzaro was assigned as the final inspection engineer. That meant he had access to the ship for 72 hours before the Navy took possession. On February 26th, a merchant marine captain named Robert Hayes visited the shipyard. Hayes was scheduled to command the Peary. He was 41 years old, Charleston, South Carolina. He'd survived 2 sinkings already, once on the SS David Starr Jordan, once on the SS Timothy Pickering. Both times, torpedoes. Both times, Hayes had made it to a lifeboat. Hayes found Lazzaro in the Peary's engine room. They talked for 20 minutes. Hayes asked about the hull thickness. Lazzaro told him, 5/8-inch steel plate, standard specification. Hayes asked if there were any modifications for torpedo resistance. Lazzaro said no. Navy hadn't authorized any. Hayes looked at him for a long moment. Then he asked, "Is there anything you could do?" Lazzaro had never met Hayes before, but he recognized something in the captain's eyes, the look of a man who'd already drowned twice and was about to go back into the water. "If I did something," Lazzaro said, "I'd be violating about 6 different Navy regulations. I could lose my contract, maybe face charges." Hayes nodded. "But could you do something?" Lazzaro thought about Hendricks, about Fisher, about Chen, about the 37 ships and the hundreds of men. "Yeah," Lazzaro said. "I could do something." Lazzaro worked alone. He couldn't involve the shipyard crew, they'd have to report it. He couldn't tell his supervisor instant termination. He had to do it himself at night when the yard was empty. He started at 11 p.m. on February 27th. The solution was simple. Mix standard concrete, Portland cement, sand, aggregate. Construct wooden forms against the inner hull, midship section, both sides. Pour concrete into the forms. Let it cure for 48 hours. Remove the forms before the Navy inspector arrived. The concrete would be 4 inches thick. It would cover a 30-foot section of the hull, the most vulnerable area, right where torpedoes typically hit. Total weight, about 8 tons. Not enough to affect the ship's performance. Not enough that anyone would notice unless they were specifically looking for it. Lazzaro worked through the night, mixing concrete by hand, pouring it into forms, smoothing it. The engine room was cramped and dark. Sweat soaked through his shirt. His hands cramped from gripping the trowel. He knew exactly what he was risking. Unauthorized modifications to a military vessel. Possible sabotage charges if something went wrong. If the concrete caused structural problems. If the ship developed a list. If it affected performance in any way. He'd be responsible, but if it worked, Hayes might survive. The crew might survive. Lazzaro finished at 4:30 a.m. 8 tons of concrete, curing against the Peary's inner hull. He cleaned up, hid the tools, went home. The Peary launched on March 1st. Navy inspectors signed off. No one noticed the extra weight. Captain Hayes took command. The ship sailed for England on March 8th, carrying aviation fuel and ammunition. Lazzaro didn't sleep that night, or the next 6 nights. At 2:17 a.m. on March 14th, the SS Robert E. Peary was 600 miles east of Newfoundland. The convoy was moving at 8 knots. No moon. Heavy cloud cover. Conditions perfect for U-boats. U-522 had been tracking the convoy for 3 hours. Kapitän Lieutenant Herbert Schneider identified the Peary as the highest value target, lowest in the water, which mean T fully loaded. Probably fuel or ammunition. A good kill. Schneider fired from 400 yards. Perfect targeting solution. The G7e torpedo ran straight and true. Impact at 2:17 and 34 seconds. Exactly where German doctrine specified. Waterline, midship, engine room. Chief Engineer Harold Bennett was at his station when it hit. He heard the explosion, felt the deck heave. The lights went out. Emergency lighting kicked in. The engine room filled with the sound of rushing water. But the water wasn't coming in fast enough. Bennett grabbed a flashlight, checked the hull. The torpedo had hit. He could see the impact point, a massive dent in the steel 8 feet across. The outer hull was breached, but the inner hull was holding. The concrete had cracked. Chunks had broken away. But it had absorbed enough blast energy to prevent the steel from tearing. Water was coming in through small fractures, not through a massive hole. The bilge pumps could handle it. Bennett grabbed the phone, called the bridge. "Captain, we're hit, but we're okay. Hull is holding. We can stay afloat." On the bridge, Captain Hayes couldn't believe what he was hearing. At 2:19 a.m., Hayes ordered damage assessment. The report came back impossible. Torpedo hit confirmed. Outer hull breached. But no catastrophic flooding. The ship was taking on water, but slowly. Manageable. Hayes had survived 2 torpedo attacks. He knew what they felt like. He knew how fast Liberty ships went down. This wasn't right. They should be sinking. By 2:30 a.m., Bennett had the situation under control. The concrete had taken the hit. The explosion had pulverized about 4 feet of it, but the rest was intact. The steel behind it was dented but not torn. Water was leaking in through stress fractures at maybe 200 gallons per minute. The pumps were handling it easily. The Peary stayed with the convoy. By dawn, they'd patched the worst leaks with emergency seals. The ship was listing 3 degrees to starboard, but stable. They reduced speed to 6 knots, made it to Liverpool 8 days later. When the Peary reached port, Navy engineers swarmed the ship. They found the concrete immediately. They couldn't understand it. There was no record of this modification, no authorization, no approval. But they couldn't argue with the results. The ship had survived a direct torpedo hit. The crew lived. The cargo arrived intact. They started asking questions. Who installed this? When? Under whose authority? The investigation took 3 days. Navy engineers traced everything back to Lazzaro. He admitted it immediately. Explained exactly what he'd done, why he'd done it, how he'd calculated the blast absorption. The Navy had 2 options: court-martial him for unauthorized modification of military equipment, or test whether his illegal solution actually worked. On March 28th, they ran controlled tests at the Aberdeen Proving Ground. They built steel plates backed with 4 inches of concrete, detonated explosive charges against them, measured the results. The concrete absorbed 68% of blast energy. The steel behind it showed minimal damage. Without the concrete, identical charges punched clean through. By April 2nd, the Maritime Commission had a decision to make. They could punish Lazzaro and pretend his modification never happened. Or they could admit that a civilian contractor with no naval engineering background had solved a problem that Navy engineers had declared unsolvable. Captain Hayes submitted a formal report. He was direct. The concrete modification saved my ship and my crew. I request that Engineer Lazzaro receive commendation rather than court-martial. 3 other Liberty ship captains who'd survived torpedo hits that month wrote similar letters. Someone started checking. Lazzaro hadn't just modified the Peary. He'd been doing it for weeks. After the Peary survived, Lazzaro had gotten bolder. He'd modified 4 more ships in late February and early March. Always at night, always alone, always the same 4-inch concrete layer in the midship section. The SS William Bradford took a torpedo hit on March 19th, survived, made it to port. The SS Richard Caswell took a hit on March 23rd, survived, lost some cargo, but the crew lived. The SS Francis Marion took a hit on March 28th, survived, limped into Halifax with a 12-degree list but still afloat. By early April, 5 Liberty ships had survived direct torpedo hits that should have sunk them. Navy statisticians noticed. The standard survival rate for torpedoed Liberty ships was 11%. These 5 ships had a 100% survival rate. Someone found the pattern. All 5 had launched from Baltimore. All 5 had been inspected by the same engineer. All 5 had unauthorized concrete modifications. Other shipyards started asking questions. Captains were requesting ships from Baltimore. Word was spreading through the merchant marine community. Baltimore ships don't sink. On April 8th, the Maritime Commission called Lazzaro to Washington. The meeting lasted 4 hours. Lazzaro walked them through everything: the math, the material science, the construction process, the cost, about $400 in materials per ship, maybe 12 hours of labor. Navy engineers tested his numbers. They checked his stress calculations. They reviewed the damage reports from all 5 surviving ships. The conclusion was unavoidable. The modification worked. It was simple, cheap, and effective. And it should have been part of the original design. But officially crediting a civilian contractor for solving this problem would mean admitting that Navy engineers had missed it, that hundreds of sailors had died because the Navy rejected solutions without testing them, that the whole procurement bureaucracy had failed. So they made a deal. No court-martial, no official credit, but they'd integrate the modification into new construction. Every Liberty ship built after April 15, 1943, would include concrete blast absorption layers in the hull. It would be listed in the specifications as structural reinforcement, no mention of torpedo defense, no mention of Lazzaro. The modification spread quietly. Baltimore first, then other East Coast yards, then the West Coast. By June 1943, every new Liberty ship had it. By August, they were retrofitting older ships. German submariners started reporting strange results. Torpedoes hitting targets. Explosions confirmed, but ships staying afloat. U-boat commanders couldn't understand it. American Liberty ships were supposed to be easy kills. Now they were surviving. In July 1943, U-boats sank 14 Liberty ships. In August, 9. In September, 6. The numbers kept dropping, not just because of better convoy tactics or more escort destroyers, because the ships themselves were harder to kill. German naval intelligence sent divers to examine sunken hulls. They found the concrete, reported it back. Kriegsmarine engineers tried to calculate how much the modification would weigh, how it would affect American shipping capacity. They assumed it was expensive, difficult, resource-intensive. They never guessed it cost $400 and could be done in one night by a single engineer. The Navy's official evaluation came in October 1943. The report was classified but direct. Concrete hull reinforcement has proven effective in increasing survivability of Liberty-class vessels against torpedo attack. Recommend continued integration into all new construction and retrofitting of existing fleet where practical. Lazzaro's name appeared nowhere in the report. By November, the modification was standard on all Liberty ships. Engineering textbooks were updated. New contracts included it in the base specifications. The Maritime Commission published revised construction guidelines with detailed instructions for concrete installation. They never called it Lazzaro's modification. They called it internal blast dampening or auxiliary structural reinforcement. Official histories would later credit ongoing engineering improvements for increased Liberty ship survival rates. But the numbers told the real story. Between January and April 1943, 47 Liberty ships were torpedoed. 6 survived. That's a 13% survival rate. Between May and December 1943, 62 Liberty ships were torpedoed. 41 survived. That's a 66% survival rate. The difference was concrete. Captain Robert Hayes survived the war. He commanded the Robert E. Peary for 14 more months, completed 31 convoy runs, and delivered over 40,000 tons of cargo to Allied ports. He retired in 1946 and returned to Charleston. He died in 1979 at age 77. Chief Engineer Harold Bennett stayed in the Merchant Marine until 1950. He served on 7 different Liberty ships. He never forgot the night the torpedo hit the Peary. He knew they should have died. Years later, he'd tell the story to his grandchildren. We got hit by a German torpedo and didn't sink. Everyone said it was impossible, but someone had made our ship tougher than it was supposed to be. Joseph Lazzaro continued working for the Maritime Commission until 1945. He supervised construction of 89 Liberty ships. None of them sank due to torpedo damage. After the war, he went back to Brooklyn and rejoined his father's construction company. He never received official recognition. No medal, no commendation, no mention in Navy records. When asked about his wartime work, he'd say, "I poured concrete, same as I always did." But historians eventually found the paper trail, the inspection reports with his signature, the damage assessments from surviving ships. the pattern that couldn't be coincidence. In 1987, a maritime historian named Dr. Ellen Bradshaw was researching Liberty ship survival rates. She noticed the Baltimore anomaly. She tracked down the construction records. She found Lazzaro's name on every surviving ship. She found Lazzaro himself in 1989. He was 80 years old, still living in Brooklyn. She interviewed him for 3 days. He told her everything: the sleepless nights, the unauthorized modifications, the concrete poured in darkness. Bradshaw published her research in 1991. She estimated that Lazzaro's modification saved between 80 and 120 American lives directly, probably more indirectly, as the increased survival rate changed German submarine tactics and forced them to waste multiple torpedoes per target. Lazzaro died in 1994 at age 85. He never sought recognition, never contacted the Navy to request his story be included in official histories, never wrote a memoir. But he stayed in touch with Captain Hayes until Hayes died in 1979. They'd talk on the phone every March 14th, the anniversary of the torpedo hit. Hayes would thank him. Lazzaro would say it was just concrete, nothing special. "You saved my life," Hayes would say. "I just did my job," Lazzaro would reply. After Bradshaw published her research, a few veterans groups tried to get Lazzaro a Presidential Citizen's Medal. The Navy declined to support the nomination. Official position: insufficient documentation of individual contribution to wartime innovations. But the concrete is still there. Some Liberty ships still exist. Museum ships, memorials. The SS Jeremiah O'Brien in San Francisco. The SS John W. Brown in Baltimore. If you go aboard, if you go down into the engine room, if you look close at the inner hull midship, you can still see it. 4 inches of concrete, poured 80 years ago, by an engineer who couldn't get approval to save lives. That's how innovation actually happens in war. Not through official channels or engineering committees, not through bureaucrats weighing cost-benefit analyses. Through people who see a problem, know the solution, and don't wait for permission to do what's right. Through 34-year-old engineers who pour concrete at midnight because captains are about to die, and someone has to do something. Lazzaro's modification became standard on every Liberty ship built after April 1943. Over 2,700 ships. That concrete is still mentioned in modern naval engineering textbooks as an example of effective blast mitigation. They still don't usually mention his name. But Captain Hayes mentioned it. Harold Bennett mentioned it. The 80 to 120 men who survived torpedo hits because their hulls had 4 extra inches of concrete. They mentioned it to their families, to their children, to anyone who asked how they made it home. Each one of those lives mattered. Each one deserves to be remembered. If you found this story compelling, please like this video. Subscribe to stay connected to history's most incredible untold stories. Leave a comment telling us where you're watching from and if you've ever heard of Joseph Lazzaro's concrete modification before. Thank you for keeping these stories alive. Thank you for remembering the engineers, the mechanics, the people who didn't wait for permission to save lives.